This video is about perfect squares. The first thing I want you to do is in the top right hand corner write your first and last name on Kami. And then we're going to go ahead and fill in the definition of a perfect square. A perfect square is the result of an integer being multiplied by itself. An integer being squared. So take a moment here, make sure you have the right font size and the font that you want, and go ahead and type in the word integer and the word itself. And then I'm going to grab a pen, and we're going to look at this first square together. So this first square has side lengths of 3 meters. On the picture, I want you to add this symbol on each side. This symbol is the symbol for congruent. So that means that each of these sides is equal. Now I want you to fill in the 90-degree angles in the corner. Remember, a 90-degree angle is also called a right angle. For it to be a square, you need 4 90-degree angles and 4 congruent sides. To find the area of a rectangle, we would use the formula length multiplied by width. You can use that same formula for a square, or more commonly, people for a square will use the formula area equals side length times side length, because we don't need 2 different variables since both side lengths are the same. More commonly even than s times s, people will write it area equals s squared for the area of a square. And let's go ahead and fill this in for the first square. Area equals 3 squared, and then we'll write out the work. The power of 2 tells you how many times to record the base. This is review from 6th grade. So we record this base 3 2 times, and 3 times 3 gives us 9, and this would be meters squared, or you could say 9 square meters. And this right here, the 9, is the perfect square, because we took an integer and we multiplied by itself to get this 9. Remember, an integer includes numbers like 1, 2, 3. It also includes 0. It also includes negative numbers like -1, -2, -3, -4, etc. It doesn't include decimals and fractions. So an integer being multiplied by itself will give you a result of 9 in this case, which is a perfect square. Example 2. The side lengths in this square are 7 inches. The area is equal to length times width. That's one formula you can use. Or for a square, you can just use area equals s squared, the side length squared. We're going to plug in 7 for our side length. And then we'll write that out. The 2 tells us that we record the base 2 times. We multiply this to get 49, and this would be inches squared, or you could say 49 square inches. This number is also a perfect square. Mathematicians saw these special numbers like 9 and 49, and they wanted a name for them. And they realized, well, these numbers are the area of a square that has a side length that is an integer. So the area of this square is 49. The area of this square is 9. And so they decided, well, a good name for these numbers would be perfect square numbers, or for short, you can just call them perfect squares. All right, here's the definition again. I hope you remember the terminology, and go ahead and fill this in on Kami. Perfect square. The perfect square is the result, or you could say the product, of an integer being multiplied by itself. Remember, the result of a multiplication problem is called a product. Now, this is really an activity, this next slide, because you're supposed to already have memorized all the way up to at least 11 times 11. Actually 12 times 12, but this is what I have on this page. So pause the video, fill in all of these from memory, and then press play and see if you filled this in properly. All right, hopefully you paused it and did that, and let's check your work. So did you get 0 times 0 to be 0? I hope so. 1 times 1 is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. You should be checking your work right now. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. And 11 squared is 121. Now sometimes kids get confused about what part is the perfect square. The 2 is not the perfect square. The 2 is the integer that's being multiplied by the other integer. The perfect square is actually these numbers that are recorded in yellow. So these are the ones you should already have memorized. All right, let's go on to our next set. This year, you have to memorize all the way up to the perfect square that results from 20 times 20. Now, I put on this page 12 times 12 because we're going to use 12 times 12. We're going to build off of that to come up with the rest of these perfect squares that you probably don't have memorized yet. You might. It'd be great if you did already. But let's talk about some ways to remember these new perfect squares. So 144, what that tells us is that we're still in the 100s. And then the way I remember 13 times 13, what that equals, is I think about the multiples of 3. So if you count by 3s, 3, 6, 9. 13 squared is equal to 169. All right, 14 times 14, we're still in the 100s. You'll see this whole column right here, we're in the 100s. We're still going to use the 9, and we're still going to use the 6 from the last perfect square, and we get 196. This is just a way to help you to try to remember it. All right, moving on from 14 squared, we're on to 15 squared. For this one, what I think about is 5 squared. 5 squared is 25. Then I think about it, am I still in the 100s? Well, we were almost at the 200s, so logically you should think about how we would be in the 200s. So 15 times 15 is 225. Now, this is low 200s, so we're still in the 200s. And then for 16 times 16, I just write in the 6 first. Another way to remember this would be to build off of the last number. We keep doing this. Take this 25 from the last number, and that's the start of 16 squared. So 16 squared equals 256. All right, for 17 squared, we're still in the 200s in this column. And then it's as easy as counting 7, 8, 9. All right, for 18 squared, well, we were almost at 300, so over here in this column, we move up to the 300s. And one way you could remember it is that 8 times 4 equals 32. All right, 19 squared. We're still in the 300s. 19 squared equals 361. You can think of it this way. 3 plus 6 is 9. And then if you put the 1 from the 19 back here, you get 361. And then finally, 20 squared. Most students already know that this equals 400. You could also break down the 20s and just think of it as, well, 20 is the same as 2 times 10. And 20 over here I could also write as 2 times 10. And then 2 times 2 gives me 4. 10 times 10 gives me 100. And then 4 times 100 gives me the 400. So those little memory tricks may not help you at all. Maybe you just want to study them. But I thought I'd share because in the past, a lot of kids have said that it's helped them to remember these perfect squares. You have to memorize this year these perfect squares all the way up to 400. It's a part of the 8th grade standard. All right. Now we're going to talk about square roots because they're very closely connected to perfect squares. So now we're going to fill in our notes on Kami. What number multiplied by itself gives you the number under the square root symbol. This is the question that I ask myself whenever I see a square root. So that's what I think through in my head. So I think, what number multiplied by itself gives you the number under the square root symbol? So what number multiplied by itself will give you 25? Here's where I want you to pause the video and think about this. All right, I hope you paused it, and I hope you came up with 5. If you came up with 5, you have part of the answer. That's not the full answer. So if you didn't come up with more than 5, there's actually 2 answers. Pause it again, think for a little bit longer. Okay, 5 times 5 would give you 25. What else multiplied by itself will give you 25? There's 2 answers. All right, I hope that you paused it like I asked and took some time. Well, the other answer is -5. Think about it. 5 multiplied by 5 is 25. And then also -5 multiplied by -5 is also going to give you a positive 25. A negative times a negative is a positive. That's something you should have learned in 6th grade compacted class. Now, mathematicians don't like to write the 5 twice. Mathematicians, if you have noticed over the years, like to write as little as possible. So they would record their answer as positive or -5 like that. And that just shows you 2 answers. It can be +5 or -5. All right, let's write in a little bit of terminology. So this symbol right here is called the radical symbol. This number underneath the radical is called the radicand. And the index, you actually don't see it in a square root symbol, but really the index is a 2. This will make more sense when we look at cube roots and fourth roots. But with the square root, the index, they hide. I think it's because the square root is used more than all the other roots. So, you know, with the purpose of saving time, if that's the one you use most often, you don't want to write a 2 every time, you don't have to. But know that the index here is a 2, the index here is a 2, the index here is a 2. All right, let's think about this next example. What number multiplied by itself gives you 121? Well, 11 times 11 gives you 121, and -11 times -11 would also give you 121. So there's 2 answers. All right, 36. Well, what's the square root of 36? Well, 6 times 6 would give you 36. So +6 is one answer. Also, -6 times -6 also will give you 36. So there's 2 answers. All right, now it's time to step it up a bit. So I want you to focus on just the square root first. The square root of 25, we already said, was 5 or -5. Now I'm going to grab another color pen to make this more clear. All right, so if you have a negative out in front, all right, the square root of 25 can be 5 or -5, and then we have a negative out in front of that. All right, well, a negative in front of a 5 makes it a -5, and a negative in front of a -5 makes it a +5, because this really means when you have 2 in a row, this first one you're going to read as the opposite. The opposite of -5 is 5. So really, the answer to the negative square root of 25 is the exact same as the answer to the square root of 25. It is -5 or 5. There's 2 answers. The square root of 0 is special because 0 is not positive or negative. It's neutral. It's right in between on the number line, the negative numbers and the positive numbers. So the square root of 0, there's only one answer to that, 0. The square root of 225, well, 15 times 15 is 225, and -15 times -15 is 225. So the square root of 225 is equal to positive or -15. Squaring a number is the opposite of taking the square root. Go ahead and type that in on your Kami notes. They are, and I want you to take your drawing tool on Kami and underline, they are inverse operations, or maybe you want to circle it. They are inverse operations of each other. So taking the square root is the opposite of squaring a number. Squaring a number is the opposite of taking the square root. This is just like our inverse operations with, addition and subtraction. Addition is the inverse operation of subtraction, just like subtraction is the inverse operation of addition. Multiplication is the inverse operation of division, just like division is the inverse operation of multiplication. It goes both ways. Take a look at what I mean. When you square 5, you end up with 25. When you square negative 5 times negative 5 is also 25. Well, if you want to get back to the 5, the opposite would be to apply the square root symbol. The square root of 25 is 5 or negative 5. Look down here at 11 squared. 11 squared equals 121. Negative 11 squared equals 121. And if you want to get back to 11, you have to do the opposite, which is taking the square root. The square root of 121 is positive or negative 11. I want you to see how closely squaring and taking the square root are connected, because for this standard, we also need to be able to look at square roots and move the opposite direction. So let me show you what I mean. Well, I need to grab a pen again. You'll want to grab a pen too. You can type or you can draw. The square root of 0 is equal to 0. The square root of 1 is equal to positive or negative 1. The square root of 4 is equal to positive or negative 2. The square root of 9 is equal to positive or negative 3. Remember, you're thinking about what number multiplied by itself gives you 4. Well, 2 multiplied by itself gives you 4. So if you're trying to come up with this number, you can just take this number and square it. So negative 4 times negative 4 gives you 16. Or you could think of the positive one. 5 times 5 is 25. Now that you're getting the hang of it, just so that you practice, let's see how many you have memorized. So pause the video, fill all of these in on your own, and then I will fill them in a moment, and you can check your work. This will be your first test in seeing what you learned already, what you already have memorized. So use the tricks that I taught you and fill those in. All right, hopefully we're at the point where you paused it, you filled it in, and now we're checking our work. So you should have a 36 here. 49, the square root of 49 is positive or negative 7. 64 here, be looking at your work. 81, 100, 11 squared is 121, so the square root of 121 would give you 11 or negative 11. This would be 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared, we're into the 300s now, 324. 19 squared, 361, and then 20 squared is 400. And we want to be able to think about it the opposite way, where we say the square root of 400, well, that would be positive or negative 20. The square root of 225 would be positive or negative 15. So this is the final page in our notes for today. Be working on memorizing your perfect squares up to 400. And know that the numbers that we're writing in yellow, the 400, the 196, the 64, the 16, those are your perfect square numbers. The 2, that's not your perfect square number. That's the integer that's being multiplied by itself to give you the perfect square number. So memorize those perfect squares up to 400, and that is the end of your notes for today.